My name is Zach Denkos, and this is my NE 4506 self-fabricated ion chamber for radon gas detection project. In this video, I'm going to run through a demonstration of the final product, which will help us understand the principle of gas detectors, as well as the decay of the thorium series, as well as conduct counting and determine the half-life of radon-220. We have three objectives to successfully complete and accomplish this project. Objective 1, building the chamber. Here you can see the open air circuitry of my project, as well as the trip pot that's going to adjust the voltage, the place to mount the battery, and as well the aluminum wire for the ion chamber. Here is our mantle inside of the syringe accumulating radon gas over the last 3 days. Now I applied an aluminum foil shielding for the circuitry to reduce any background. I've also wrapped the bottom of the ion chamber with more aluminum foil shielding. You notice here that when the 9-volt battery is attached, I'm able to get a reading that fluctuates actually quite greatly compared to the reading without the shielding. Now I'm taking the readings and adjusting the trimmer pot to try and zero out the voltage difference. Objective 2, finding and understanding the thorium decay series. Looking at the NUDAT chart of nuclides, starting at thorium-232, we know that thorium-232 will decay via alpha, which means it will drop 2 neutrons and 2 protons and decay down to radium-228. From there, radium will gain a proton and lose a neutron, decaying via beta minus to actinium-228, which will also further decay via beta minus to thorium-228. Thorium-228 will decay via alpha, losing 2 neutrons and 2 protons, decaying down to radon-224, which will further decay via alpha emission down to radon-220, where we notice in the bottom left corner our source of radon gas from our mantle has that half-life of 55.6 seconds and is emitting those alpha particles being detected by our ion chamber. Objective 3, injecting radon gas and measuring the half-life of radon-220. After injecting the radon gas, I keep recording counts every 10 seconds for the course of 5 minutes, and this should account for covering about 5 half-lives of radon gas. Here I accumulated all of the data and plotted it on a graph plotting count versus time. From this, I was able to use a curve fit and calculate the half-life of radon gas, which is noted here. My voltage readouts after exerting the radon gas into the ion chamber demonstrated quite a small order of magnitude, however, did portray the negative exponential that we would expect as the half-lives take place. Overall, this project works definitely as a proof of concept, and in order to gather more distinguishable results in terms of understanding the voltage difference, this will help us better analyze the half-life of radon-220 and output those readings onto a plot.